even though we are in the rush, we have to answer to a bit. We need to go fast on constructions, always faster and so on, always cheaper and so on. Having this model, accessing to this science is definitely, I would say today, what we should care about. And this is where also AI can also help us step by step to accelerate.
This series of episodes was recorded live at Digital Construction Week 2025 at the Excel in London. I got the privilege of interviewing some amazing people that are shaping the future of the built environment through the technology that organizations are developing and delivering now and for the future. Although this podcast was worth the entry fee alone, let's admit it, now is the time to register your interest for next year's Digital Construction Week 2026. But if, like me, you can't wait until next year, check out Digital Construction North on the 19th of November. The links to both events, as always, are in the show notes. But just before we go live with this week's episode, here's a brief intro to the topic we cover and today's guest. Digital innovation is driving profound changes across the construction sector, offering new ways to rethink how buildings and infrastructure are conceived, delivered, and operated. From the emergence of advanced modeling technologies to the application of artificial intelligence and manufacturing principles, the industry is moving towards a more connected, efficient, and sustainable future. But we know all of this, we've covered it in extensive detail on this podcast. But when it comes to lean construction, it can get a little confusing as construction in itself is anything but lean. We need to chat to someone who can help us lean into this topic and shed some light on its importance. With 16 years of experience at Dassault Systems, Remi Dornier has been committed to his passion of deep interest: geosciences, architecture, engineering, and construction, AEC, sciences and technology. Working in close collaboration with industry, research institutions, and governments, he focused on leading business transformation in aerospace, naval, industrial equipment, and the AEC industry in both mature and emerging markets, with 7 years in France and 8 years in Asia. So first and foremost, welcome to the podcast.
Thank you.
And let's start by telling the listeners who you are and what you're doing at Digital Construction Week.
Okay, so I'm Remi Dornier, and I'm leading in Dassault System, the architecture, engineering, and construction industries. And basically, Dassault System, we are, I would say, scientist companies who deliver virtual universes for constructions. So virtual twins for constructions in order to secure the executions and, I would say, the engineering of the constructions.
Yeah, fantastic. So that is at the pinnacle of digital, really, virtual universes. Yeah, excellent. Okay, so what I want to start with is this phrase, lean construction, and the journey of lean construction over the past few decades and the fundamentals behind it. Could you just explain that a little bit more?
Yeah, I think I can explain a few things. I would say first the story, and lean constructions. The lean process comes from the automotive, right? Initially.
Yeah.
And when it comes to Dassault System is very well known when it comes to speak about industrializations. We have been, I would say, leading the sector of industrializations for automotive, for airplanes, and so on. And basically, we succeeded there because we anticipated. How did we bring the anticipations? We brought the anticipations thanks to digital, thanks to virtual twin. And the lean principles today, this is to, I would say, work against leakage and so on. And one of the objectives that we have since the early beginning, this is to guide, I would say, constructions to more industrialized practices and to leverage lean approach. And to give you a story, when I arrived on one field, I remember, I would say, a worker telling me, Remi, you know nothing about constructions, and but you know everything about digital. And me, I know everything about constructions and I know nothing about digital. And this is very good like that. Say, okay, well, that's not a good introduction, but maybe we have something to learn from each others. And what about, I would say, talk about not the virtual twin, will be maybe not the right entry point, but what about the lean approach? And we started to speak about the lean approach, explaining how we handle routine, how we identify, I would say, some leak, some issues, and some bottlenecks, and so on, how we can gather the teams to think about that. And from this, we build very efficient lean practices. And guess what? From the lean practices, people say, okay, now I understand how to better anticipate, how to make my routine, how to make a 3 weeks, I would say, planning and scheduling. Do you have a tools to make, I would say, a better schedulings? And then we arrive from the lean to the virtual twin approach, for examples.
Okay, that's really cool. So you did learn from each other.
We did learn from each other's. And I would say the lean gave us a way to go to the virtual twin approach.
Yes. Okay.
Which could be perceived as complex at the beginning, but which is needed when you just want to get better organized.
Yes. So as with everything in the construction industry, there's always challenges. Okay. And there's sort of 3 big challenges here that I'd like you to sort of address, which is environmental, economic, and human. How are we addressing those challenges?
I think there are 3 challenges today. Sustainability, and it's a huge challenge.
Yeah.
So regulations. Regulation is definitely shaking the ecosystem of the constructions, with the energy first, with the carbon now, with the waste management. And guess what? In fact, with the sustainabilities, you have now the architect that used to have difficulty to comply between the customer demands and the cost of the project, which now have to make sure that carbon-wise, what they have to think about flies somehow. And for this purpose, they are starting to change a lot the materials on the constructions. So where you used to have concrete-only constructions, now you have concrete and wood constructions because it helps to decarbonate, for example.
Yeah.
So imagine now the general contractor, he has to comply with different construction methods. So I was in the field, I would say a few months ago, where the guy had put concrete and then there is one floor with only stones because it was local stones and it was good for decarbonation. And the guy told me, I didn't build stones for 30 years. So I'm taking risk in order to develop these new construction methods for me.
Yeah.
And then you realize that this impact about sustainability, environmental impact, is bringing today a big change, a big transformation inside the constructions domain, because construction methods are evolving, getting more and more hybrids. And then, in fact, architects have difficulties to identify the best one. And then they start to shake literally the construction ecosystem. So environmental number 1 reason, this is the sustainability, who is pushing the construction ecosystem for change.
Yeah.
Number 2, economical wise, I think this is productivity. So today, productivities, the material inflations, the margin has been, I would say, never as low as it is right now on constructions. Even, I would say, productivity is decreasing. And I think we have to tackle a new challenge for that. We need to invent not mass productions. Mass production for construction does not exist because every building is different and so on. But we need to tackle, I would say, what I call personalized productions, meaning how to industrialize unique buildings.
Yeah.
And this is why we need to tackle and count, I would say, for the economical challenge. The third one, I would say, regarding the human challenge, I think this is skill scarcity. Today, we face difficulty to find skilled people, plumbery, electricity, and so on. And I have a question there that come back to, I would say, the environmental aspect is that since we have to change, can we develop more polyvalence? By polyvalence, instead of being gathered and organized per domain, can we think about people who are multi-trade and which can take over, which is this lack of this skill scarcity that we are facing?
So you think it's going to be multifaceted in terms of the people that they're going to have multiple skills?
Yeah. In fact, part of, I would say, the example we've been, I would say, working on. So in Dassault Systems, we work in virtualizing knowledge know-how. So usually knowledge know-how, this is the experience of people.
Yeah.
What we do, we help those guys to virtualize their knowledge and people so that we can standardize the methods. And this, by standardizing those methods, you can reuse them in a proven way from one project to another. And thanks to that, you can get more productivities and more efficiency. And to answer to your questions, we made this on, so we call this a brick, okay? It's a brick. And this brick, you will virtualize inside the know-how, for example, to make a service riser.
Okay.
So your plumbing networks and your electrical networks in order to, in fact, plug every apartment to water and to the electricity. So this, you could decide to make a kit of parts of this kind of things. And this is what we did. So we took a plumbers and we put the knowledge and the know-how inside the bricks.
Okay.
And we put that on the shelf. Then from this, we can reuse that inside the project. And on this project, we took a multi-trade components. This guy used to have a garage and he lost his job and then he went in constructions. So he had no construction skills. But being able to consume those methods that were virtualized and so on, he was able to build this today technical riser system.
Wow.
So in this context, yes, I believe that the polyvalence will help. Tomorrow, we will not replace plumbers, but with such, I would say, flexibility, we will be able on key bottlenecks to use more polyvalent people.
Okay, that makes sense. Really interesting, very different approach to what's traditionally been seen as developing skills as well, which goes with technology, which is fantastic.
Yeah, exactly. Yeah.
Cool. So I want to move on to the 5 principles, if you like. So if I just outline them, so focus on goals, communicate visually, obsess over the plan, notice flow, and understand the human element. So if we just focus on one at a time, and this is to do with lean construction and better efficiencies and things like that, how do we make sure people are focused on the goals that we need to achieve?
I would say less is more.
Okay.
Today. And we work a lot on simplifying, making sure that every individual on the value chain of a project is focusing on what he is accountable for too.
Yeah.
And today in constructions, 10 years ago, beam, I would say promise, was raised. People had huge hope on the beam, but in fact, on the beam, everybody started to model everything in the same model.
Yeah.
What we are trying to do now, we are trying to leverage some practice coming from the manufacturing sectors where somehow everyone has only to do what they are accountable for. So to give you an example, we spend quality time to develop what we call concurrent engineering practice. In 1989, we developed with Boeing an approach which aims not to make the synthesis of an object, meaning that you ask engineers, can you give me your 3D? Can you give me your 3D? And then you mount the model of an airplane.
Yeah.
But we said, instead of doing that, guys, nobody will knock at your door. You are accountable to post your 3D on one single platform. So we call that concurrent engineering. By doing that, we were seeing the airplane evolving all the day with all the parts. So we were seeing the fluids coming, we were seeing the structure coming, we were seeing clash and so on. And you didn't have a beam coordinator trying to mount everything for everyone. So today, we have been working on this approach. And thanks to such an approach, we were able to get rid from 7 prototypes to 1 prototype.
Nice.
So by leveraging such methods, clarifying ownership, you do and you model on your model what you are accountable for.
Yeah.
So I would say, an architect. I'm an engineer. I will only focus on the computations. And I'm a general contractor. If I subcontract, I care about the interface, because the interface, this is where I will get conflict on the team, on the field, and so on. But I will not model the details of the building if I subcontract. I have no knowledge. So what I will model will be wrong. So step by step, I learn work package per work package to detail what I own if I self-perform, and I learn to not detail what I don't own. So less is more. And I would say today, digital continuity can help to bridge all the story, make sure all the parameters exist where they have to be formulated with the ownership. And then, in fact, this is the continuity between the data that will bring the story, the model of the constructions and make it simpler with, I would say, a smoother flow and so on, so that we can focus on our task.
Mm-hmm.
So an example, coming back on the brick.
Yeah.
So we have been virtualizing the know-how, for example, for a concrete model. And the concrete model, you need a model for the formwork. You need a model for the mannequins that you need to put in order to cast the concrete and so on. So we simplified very much with such an approach the drawing we give to the worker. The drawing we give to the worker now has only the required information for the task itself.
Yeah.
And all the rest will be in another activity. And step by step, such a simplification was very welcome on the field because people are overwhelmed with too much information, which is very difficult for a human, I would say, for a human to link together.
Well, you mentioned two things there. It's the simplification and also the accountability. And it's amazing what happens when you give people that accountability. You know, when you give them the freedom to say, it's your responsibility, straight away, it's that ownership, isn't it?
But one rule, if you don't know what you don't know.
Yeah.
So an engineer will never model a construction's methods. Otherwise, we'll be wrong.
Mm-hmm.
And what the workers will read the drawings, say, I don't need that. It's not how we build a building. And today, we have too much stage 5 drawings, for examples, which are inaccurate.
Right.
Completely inaccurate. Then you have the general contractors, which is facing claims for the subcontractor. And then you have the architect, which have the duty in England to deliver stage 5 drawings.
Yeah.
But they never build.
Okay, so speaking of that, what about communicating visually then?
So 3D is a common language for everyone. And basically, so it has been at the heart of our visions.
Yeah.
I didn't mention that, I would say initially, but it's interesting to position Dassault system. We might not be well known in constructions domains.
Yeah.
But if you watch B1M channel, on B1M channel, I would say there is a documentary called Guggenheim Museums.
Okay.
That has been done by Frank Gehry. And he is explaining how, by using virtual twin, how by using 3D, he has been able to secure on time, on cost, the constructions of this museum.
Okay.
How? By, first of all, using freedom to shape and to draw whatever he wants to these Guggenheim museums. Nothing is straightforward, right?
Yeah.
And then turning that to, I would say, an industrialized approach. Without 3D, you could not do that because from the shape, we have to go through the construction systems that will hold the shapes, the assembly that will build the shape together and so on. And this is what 3D enable, is to make a very detailed models that makes things constructible at the end. So we use this very much. The 3D is at the heart of everything. Always gives, I often get angry when we speak about data lake and so on. Say, okay, guys, but you have the puzzle pieces. But if you miss the model, you have puzzle pieces, but you cannot build the story.
Yeah.
So today, the 3D, this is somehow the combination of all the parts in the story that makes things possible and so on. And this is why we put this at the heart. So after 3D can sometimes also be useful to reveal invisible. So what I mean by that is that a noise study, a wind study, very difficult to explain to a mayor. I would say, if you build this building shape, you will create a lot of wind in this area. If you reveal that in 3D, if you show how the wind behaves in 3D, people understand. And it's a wonderful tool of decision making today that we are using to reveal the invisible.
Okay. So we spoke about communicating visually and focusing on the goals. What about obsessing over the plan and sticking to a plan? How important is that? Because you want to communicate visually, and you want that, like you're saying about the Guggenheim Museum, that flexibility to
The plan is one thing, but I would say if the plan is not accurate, you can put that in the bin
Okay.
and and you don't need plan, right? So I will insist on the fact that the beauty of, I would say, today technology, that we are providing virtual universes in order to model beforehand something real.
Yeah.
And this is why we call virtual twin. We model something virtual to make sure that in real, it flies, it works, and then it will be feasible.
Yeah.
And today, this model, this scientific model that explains how it works, how it operates, the performance, and so on, will give us the proof that at the end, you can build it, it will operate as planned, and it can be built as planned. So yes, I agree on the fact that we need to stick to the plan, but before everything, you need a model. You need today a model that will guarantee that the plan that you can output is accurate, trustable.
Okay. So the one of these 5 principles I don't know much about here, and that's notice flow.
Yeah.
Can you notice flow?
Notice flow? What do you mean?
So it says exploring one of the 5 principles.
Yeah.
We've got focus on goals, communicate visually, obsess over the plan, and notice flow.
Work instructions, you mean? And
yeah.
Yes, I would say after it's and this is something also strong. When you look at the building, you see the building.
Yeah.
But when I look at the building, I see the construction projects.
Okay.
I see the crane. I see the storage zones. I see human flow. I see the material flow. I see, I would say, the way that is changing every day and so on. And today, the notice of flow is extremely important, okay? Because we need to describe how.
Yeah.
How I will build, I would say, this specific phase, the specific buildings, and so on. And today, in fact, the virtual twin approach can help you also to focus not only on the what I need to build, but the how I need to build this, and to make sure that you secure all the information people will need, storage zone, material flow, procurement list, and so on, so that they can operate efficiently on time without occurring any conflict with the other teams on the field, for example.
Okay, right. That makes sense. So you've got this obsession over the plan to make sure it's accurate, but you need to understand that things change and making sure the operation has that flexibility as well.
Yes, exactly.
Yeah.
Exactly. We work a lot with facade makers. So Zahadid, for example, has been using our solution a lot to build a very complex system of facade. And again, here, you start from a crazy shape. And from this shape, will happen something that needs to be constructed. And with all the ultimate details, the precisions, the accuracy of the connection systems, and so on. So you have to think about the flow of organization, of assembly, of installations to make sure that things will be able to operate as I was expected at the beginning.
So one thing that adds to that complexity is the human part of it. So how do we go about understanding how that human element impacts our construction then?
There would say 2 things. So first of all, I mentioned sustainability at the beginning, okay? And the sustainability consequence is a better living environment for everyone, right? And decarbonation is not an easy thing to perform.
Yeah.
So today, our model is definitely well suited to be more sustainable, to drive more sustainability, and at the end, to support the change, to support the human change from one method to another's, so that we can make more affordable and more, I would say, sustainable constructions. So here, on this, the building performance, which has been sought beforehand across several domains, thermal, operationals, electrical efficiencies, and so on, will be much more efficient and will provide a much more living environment, a much better, I would say, living environment for mankind, for peoples, than what we have today. And today, this is also the consequence of being able to step ahead, rely on science, use models to sort beforehand and understand the impact of what we are building right now. Even though we are in the rush, we have to answer to a bit, we need to go fast on constructions, always faster and so on, always cheaper and so on. Having this model, accessing to this science is definitely, I would say today, what we should care about. And this is where also AI can also help us step by step to accelerate.
Okay, so does that link to, just moving on ever so slightly, AI and the technology in overcoming cultural and systematic barriers to lean adoption? Is this where the technology really comes into play?
The anticipation, the model, I would say being able to make a model up to the nuts and bolts is perceived as complex.
Yeah.
And it is complex in the way that to capitalize the know-how, you need to source the know-how, you need to understand the know-how, and people, most of the times, they know more than they talk about something.
Okay.
And it's very difficult today to gather and to be able to get this know-how and to virtualize this know-how. So one of our objectives, step by step. So sorry, can you repeat the question? I forgot.
Yeah, sure, no problem. So it's overcoming cultural and systematic barriers to lean adoption.
Yeah. So yeah, complexity. So the complexity. So it's perceived as complex to capitalize the know-how and so on. At the end, I think we need to hide such a complexity. But at the end, when you build the structures, you want this structure to withstand the snow, to withstand the wind, and I would say to be able to protect you, right? And all those algorithms, structural algorithms, and so on are complex.
Yeah.
So I think today with the technology, we can simplify things. We can help you, we can guide you to build a structure that will withstand some regulation and codes. And this is where today generative design, AI, will help us more and more to simplify the complexity, watching and being careful to integrate science, to make sure that this is not only, I would say, a rule of thumb that makes that things, I would say, withstand, I would say, gravity and so on, but that we are using proven rules and science for ages in order to give an answer. But this answer might be accessible to more and more people. To give you an example, we work with IKEA. And IKEA, they have, I would say, a kitchen experience. So you go on their website and you can plot, I would say, your kitchen layout. And then you will get a kit of parts that magically, I would say, can be installed in your kitchen, which is always different from one to the others. Those kitchen, they are done by Dassault System. So we do 9 million kitchen a year today. And this is Dassault System software with the promise that from someone who does nothing about modeling, who doesn't know anything about kitchen, is able to make 90% of his kitchen project. At the end, we'll go at IKEA, we will sit with an expert, we will give some corrections and so on, but 90% of the project is done. So when I speak about hiding complexity, this is those kind of things I would say that have in mind. You know nothing about kitchens, but you are able to sketch what you want according to your needs, your taste, and get a kit of parts at the end.
Yeah. So do you think that's how we'll be using AI within this field going forward? It's about doing it to 80, 90%, these different things? Or is there a different part for it to play?
AI it's an accelerator, as long as we understood what it can do. Okay, I think AI can be elevated with science, meaning that the model, the virtual twins, this is science-based, and this is leveraging science methods to make, I would say, feasible things.
Okay.
Behind that, it has a certain complexity sometimes, and this complexity could be heavily simplified with AI processes. Okay, integrating urban planning rules, writing, I would say, a program, construction programs. Okay, being able to retrieve construction program parameters and set today the bricks that I was mentioning, set the parameters on bricks I was mentioning, so that it can deliver accurate bill of materials.
Yeah,
the AI will be there. AI also will be on the understanding of the world. So here, when I would say, to do a renovation program, so we do some renovation program on individual homes, where we have to spare materials and so on. We have to capture the homes as it is, with all its specificities, understanding the reality and translating the reality to a model. AI will definitely help on that. And at the end, I think also to happen some eco designs practices and methods, which means code, cost, and I would say the code and cost, I would say, of the constructions and the carbon footprints will requires AI simplifications to make sure that step by step we can manage the design of the constructions with having in mind the carbon, the cost, I would say, and the code compliance of the constructions we are thinking about.
Okay, fantastic. So, final question from me, Remi. It's the 10th year anniversary of Digital Construction Week this week. Where do you think construction technology will be in the next 10 years?
I have a dream, and I think we always used to see people saying that I would say the AC industry is one of the last with digitized industry.
For sure.
After, I would say, fishing, fishery, I would say
Agriculture.
agriculture
Yeah.
market. I hate these statements because looks like I would say this the construction is unable to transform itself.
Mhm.
And I have a belief, I think in the coming 10 years, this is construction that will show the way. Will show the way
Okay.
of personalized constructions thanks to digital.
Right.
Making good use of AI, making good use of generative power, being able to generate structures and so on, making good use of the cloud technologies, and making good use of AI.
Yeah.
So today, we have no background, no history, no legacy. I would say, of course, there is a beam, but this is a very, I would say, a small start, I should say, in the digitization domain. So betting on what we have been capable to demonstrate, model buildings, leverage beam, start with the lean, with constructions methods, and now accelerating to be able to make personalized productions with digitals. And I guess in 10 years, it will be one of the model of, I would say today, the industry is leading in terms of technical and digital technology.
That's a great way to end this. And yeah, it's such an interesting concept and thought for the next 10 years. Remi, thank you so much for being part of this. Absolute pleasure.
Okay, my pleasure. Very happy to be here today. And I will come back whenever you want.
Amazing.
Thank you.